Hey math kids, today we're going to talk about stationary points. And so stationary points we used on a previous video are the places where the slope changes from positive to negative would be just our standard stationary points. Okay, so like a local max or a local min. And then we also have something called stationary inflection, and that's where we're going down, and then just for a moment we have a point that would have a horizontal tangent line, just like these do. And so that would also be a stationary point. Now stationary points occur when the derivative is equal to 0 because the slope of a horizontal tangent line is 0. So we need to find and classify all stationary points of this function. And so first we need to find the derivative. And then we want to set the derivative equal to 0. This one I'm going to factor out a 3. And then from there we can t-factor a negative there. So we have 3, x plus 1, x minus 3, and that is equal to 0. And if we solve that, we'll see that we get negative 1 and positive 3. Okay, with our sign diagram, we get negative 2, 0, 4. Remember, you can just choose any values that fall into these places. I'm going to evaluate it right here. The 3 is positive, so it's not going to affect anything. So I'm not going to worry about it, because timesing something by a positive number will just keep the sign the same, whatever it was before. If I plug in a negative right here, we get a negative. Plug in a negative here, negative. Negative times negative is positive. If I plug in a 0, get positive, 0, negative. Positive times negative, negative. Plug in a 4, positive. Plug in a 4, positive. Positive times positive is positive. So if we go uphill, then downhill, and then if we go downhill, then uphill, this is going to be a local max. This is going to be a local min. So we've classified these. Now the last thing we need to do is just figure out the exact points. So we know negative 1 comma something is going to be a local max. And then we know that 3 comma something is going to be a local minimum. So I'm going to plug it into the original. So I get negative 1 cubed minus 3 minus 1 squared minus 9 minus 1 plus 5. Negative 1 cubed is negative 1. Negative 1 squared is positive 1. Positive 1 times negative 3 is negative 3. These multiplied together are positive 9, and then we have our positive 5. Combine these, we get negative 4. Combine these, we get 14. Combine those, we end up with 10. So the y value right there is 10. Now I'm going to plug in a 3 to this, and I get 3 cubed minus 3 times 3 squared minus 9 times 3 plus 5. Bring this down here. 3 times 3 is 9 times 3 again is 27. This will be the same thing but negative. This is also. So those cancel, and then this is going to be negative 22. So that goes right there. And so we have found and classified all the stationary points. Okay, moving on to the next problem. Okay, it says find the exact position and nature of stationary points. So basically it's having us do the same thing. Wording it slightly differently, but same idea. Okay, now we need to find the derivative of this to start off with. It's going to be a product rule derivative. And so the derivative of A is going to be 1. derivative of b is going to be negative e to the negative x. So product rule, so this is going to be y prime. Write the first one, and then write the derivative of the second one. Add that to the second one, times by the derivative of the first one. Okay. Now, if we look at these as terms, we can take out an e to the negative x, and that's going to leave just this negative that's going to be distributed right here, and so it's going to be negative x plus 2, and then everything goes out here, so it's plus 1. If we simplify that, we're going to be left with negative x plus 3, which I'm going to swap that around and call 3 minus x. And then also e to the negative x, we can bring that down to the bottom and make it positive. So this is our y prime, that's our derivative. And we're going to set that equal to 0. So if we set it equal to 0, we multiply both sides by e to the x. E to the x cancels, that's just times by 0. So 3 minus x is equal to 0. Add x to the other side, and 3 equals x. So on our sign diagram, we have 3, 0, 4. If we plug in 0 here, we're going to get just a 1. If we plug in a 0 here, we're going to get 3 minus 0, and so that's positive. Positive times positive is positive. If we plug in a 4, e to the negative 4 is still a positive value. And then if we plug in a 4 here, 3 minus 4, that's negative. Positive times negative is negative. And so we're going to get a local max on this one. And so we know the exact position is 3 comma something, and it's a local max. And we just need to find the y value that corresponds to that. So if I plug in a 3 to the original right here, I'm going to get 3 minus 2 e to the negative 3. And so this just becomes a 1. And then if we just bring this down to the bottom, we get 1 over e to the 3. And we found the exact position and the nature of that stationary point. Okay, next one. It says find the greatest and least value of this function on the interval from -2 to 5, like that. Okay, so we're going to find the derivative, dy dx, or y prime, however you want to write it. Alright, so we have that. Let's take out a 3x. This leaves us with x minus 4. So that's going to be our derivative. Now we want to know where our derivative is equal to 0. So we're going to change that to a 0. And so we get 3x equals 0, x minus 4 equals 0, which is x equals 0, and x equals 4. Make our sign diagram. We have 0, we have 4. So I'll choose -1, 1, 5 for my values. Plug in a negative here, negative. Plug in a negative here, negative. Multiply those together, we get a positive. Plug in a 1, positive, 1, negative. Those together make negative. Plug in a 5, positive. Plug in a 5 here, positive. Those together make positive. So if we go up then down, that's a max. Go down then up, that's a min. And those are places, so this could be the max of the entire thing, or one of our endpoints could be a maximum. So what we need to do, we need to make a table. So we'll say critical value. So those are like the important values that we need to look at to find max and mins. And those could be endpoints, or they could be stationary points. critical value, and this would be the x, and then the y value that corresponds to that. So we have a minimum at x equals 0, or no, we don't, at x equals 4, and then we have a maximum at x equals 0, and then we have an end point at x equals -2, and then we have an end point at x equals 5. So those are the x values that we need to find corresponding y values to. So I'm going to make some room right here. Okay, so I'm going to plug in 0 first, because that's easy. Goes away, so 0 gives us 5. Then I'm going to plug in a 4. So 4 cubed minus 6, 4 squared plus 5. 4 times 4, 16, 64, 16. All right, I'm getting a calculator for this. Okay, so let's do 4 cubed minus 6 times 4 squared plus 5. All right, so we got -27 for that. Okay, now we're going to plug in -2 for all the x's right here. So we're going to get -2 cubed minus 6 times -2 squared plus 5. It's also -27. And then let's plug in a 5. 5 cubed minus 6 times 5 squared plus 5. And I typed in something wrong. I guess I forgot the 5. There we go. Okay. And that's -20. Okay. So obviously we're just going to choose the lowest y value for our minimum. So the least value is -27, and this happens when x is equal to 4 and x is equal to -2. Greatest value, I guess say y is equal to 5, and this happens when x is equal to 0. And that's everything for this video. If you need additional help, please come to Math Lab. Until then, calculate.